Hello, everyone. My name is Sergio Felix, and I work as a study at Google.
And I'm Soeren. I'm a software engineer at Google.
Thank you for joining us on the Migrating a Monolithic application to Microservices. Also, thank you for waiting in line for such a long time. This is the last talk of the day. Hopefully, you don't fall asleep.
Thanks for coming.
If you have any questions, we're going to have a Dory available. We'll try to mix live audience questions with the Dory. So just be aware that that's available.
Me? Getting used to the clickers. Sergio and I both work in an org at Google called Cloud Engineering Productivity. This means essentially our job at Google is to build tools to help make other Googlers more productive. Specifically, Sergio works on a tool called Loki, and I work on something called GlassPane.
To give you a little more context around this, Loki is a release orchestration tool. It basically allows developers, but mostly release engineers, a way to automate the process of managing, scheduling, planning, controlling software builds through different stages and deployments. Basically, you can think of Loki like most CI/CD tools out there. There's a concept of a flow that has triggers, and the triggers kick off a pipeline that has a bunch of steps, and then you get notifications when those steps move along. And we use these weird-looking flows to compile and build these weird-looking applications that in our team we call hybrid applications. These are applications that are made up from both open source software and internal software that gets bundled together, built, tested, and so on.
GlassPane, on the other hand, is an internal metrics platform at Google that's essentially designed to help leaders understand the health and relative performance of their projects and teams through mainly actionable insights. So today, we want to tell you a story about our journey and how we migrated both Loki and GlassPane from monolithic applications and split them up into microservices. But first, why did we decide to build Loki and GlassPane as monolithic apps in the first place? This allowed us to experiment quickly. We needed to focus on the business logic, and having a single binary really allowed us to do this while preventing initial over-design. We weren't as concerned with everything working, as beautifully as possible as long as it worked. Since we were a small team, we could also easily manage the changes just kind of by saying, you work on this thing, I'll work on this thing. It also made things, the maintenance around our binary pretty easy because we only had to do it once. It was great until it wasn't. Our teams were growing. We started getting more product requirements, and we started onboarding new team members. We started to have too much cognitive load. When we brought a new person onto the team, instead of just needing to understand the small piece they were responsible for, they had to spend a few weeks to figure out how the whole architecture of our application worked. We had to start delaying deployments to sync features across the different team members. And we had no way to independently scale certain small parts of the app that might need more resources than others. We had to scale the whole app all at once, wasting tons of resources. This made it really messy to debug. When an error happened, it was really hard to go and find the root cause. We started to feel like we had built a cage around ourselves that we were desperate to escape. And this is where microservices came in.
But what is a microservice, and where do they even come from? Before we go deep into patterns and all of that, we want to take a step back and just look at the history of where microservices actually come from. You don't know about monolithic apps. We have a single binary that gets deployed. Changing one of its internal services, as Soeren mentioned, requires the deployment of the whole application. So that's a slow velocity to production. And then, as Soeren mentioned, new engineers arrive, and they have to understand this really complex application with a large code base. And they usually have to submit PR requests, and there's a central group of people, hopefully, who have the authority to approve those changes. Again, this is slow. They also have a single database where all the services all the modules inside talk to the database. The industry then moved on to service-oriented architecture. The term was coined around 1998 by a group of people working on something called Corba. Those old enough might be able to remember. And the idea here was that you would build services a bit more decoupled than on a monolithic app, and you had 4 types: a business layer at the top, a bunch of enterprise services, and at the bottom, application and infrastructure services, all tied together with this thing called the enterprise service bus. Around that time, we wanted to share everything, and so we had a single database that was shared across all the services. The problem with this is that if you made a change to your database, that change could ripple throughout all your services. So that was a problem. Also, the enterprise service bus needed to scale depending on how many services you had, and it was a single point of failure. Then things evolved a little bit, and we got to microservices. Here, autonomous teams are organized over a single functionality. Microservices are independently deployable, and teams produce and consume APIs. This makes it really simple for other services to scale really fast and enables innovation. Also, nowadays, microservices are deploying containers, so that it gets even simpler to deploy.
So what are the benefits of microservices? Well, they're pretty simple to understand. These small services make it so that onboarding new team members is relatively easy when compared to a monolithic app, because people are only focused on the things that they're responsible for. It also allows you to work on potentially different tech stacks within your team. You might have someone working on Python for this microservice, someone working with Java for the other one. It's pretty cool. They also have isolated responsibility, which means that all the microservices are responsible for a single thing, and you can deploy them independently. They're also scalable and distributable. And you can reuse business logic throughout your application simply by making a call to a microservice that's responsible for the certain functionality that you need. They're also really fault tolerant. Later, we'll talk about some patterns you can use, like the circuit breaker pattern, to handle when a service goes down. This is something that's not quite as elegantly possible with monolithic apps. OK, those are some of the benefits. But how do I actually go about migrating a monolithic app? This is something that's really daunting for a lot of teams, right? You might have a bunch of legacy code. You might have all these different dependencies that are intermixed, and you're wondering, OK, how do I go about tackling this? Well, with both Loki and Glasspane, we had a monolithic app that we wanted to break into microservices, but we weren't sure how. We initially asked ourselves these questions, which you also might be wondering. How big should these services even be? And how do I actually go about splitting up the functionality in my monolithic app? Well, the micro part of microservices, it's kind of more of a label than a description. The size of a microservice can really vary. There's this concept called service granularity that's essentially how big are your microservices? And there's no one-size-fits-all approach for this. It's going to depend on your infrastructure and your tech stack. Ask yourself how much overhead is associated with building a new service. Consider things like source control management, deployment, testing, etc. Later, we'll talk about some tools that you can use to automate these things. Ask yourself, does creating a service cost more than implementing its functionality? If that's the case, that's a good indication your service might be too small. One approach that's commonly used is domain-driven design, which emphasizes the idea of bounded contexts, where each component of your application, or in this case, each microservice, is only responsible for a single thing. If you're familiar with object-oriented design, you can think of this as each microservice handling one strong entity and its related business logic and the data layer. Beware of an anti-pattern called nanoservices. This is essentially when your services are so small that it's not feasible to maintain them. To give you an example of this, we actually ran into this problem with Glasspane. So it started as a monolithic app running an app engine. And after our design process, we decided that there were essentially 7 domains in GlassPane. So we created 7 microservices. That was our magic number-ish. We moved from the monolithic app first to this core microservice that talks to 6 other microservices that handle their respective domains. And where we went a little too small, a little awry, is when we started making an individual microservice for every single metric that we wanted to show in GlassPane. Now, we wanted to show hundreds of metrics in GlassPane. So with that infrastructure, we would have to build hundreds of different microservices and do all of the release and testing and logging and all of the things associated with each of those, along with the complicated data logic and business logic that we might have. Instead, we took a step back. We said, OK, this is not feasible for our team size and our tech stack. We decided we'll have a single microservice responsible for all the metrics. But how do we keep that isolated responsibility principle? Well, we still had, having a single microservice allowed us to only have release and tests and logging for a single one, so it solved our problem. But we were able to take advantage of Google Cloud Functions, which provided that isolated responsibility without all of the maintenance that goes along with those separate services. So this was our solution. And maybe something similar could work for you. All right. I just talked about deciding on the size of your microservices. But how do you actually go about splitting up the functionality in your monolithic app? There's a pattern for this called the Strangler Pattern. It gets its name from the strangler vines of the fig tree, which start at the top of the tree in the leaves, and they slowly work their way down over years, potentially, until they're rooted in the soil, and they've entirely consumed the tree, and it dies. You can think about migrating your monolithic app kind of like that, slowly and creepily, and hopefully not in a forest. So to give you an example, here's a monolithic application we've got. It's a single binary. It's got some modules in it, maybe the accounting module, the shipping module, the inventory module, and they're all communicating with the same database. And when a user makes a request, the monolithic app is the only service that handles it. With the Strangler pattern, the first step to migrating this monolithic app into microservices is to add something called a proxy. Now, this is going to, initially, all it's going to do is reroute requests that are coming from your user to the monolithic app. Nothing has changed about the way your user is interacting with the app. This is just a layer you've set up so that you can begin redirecting traffic to new services as you implement them. Next, let's say we want to tackle the functionality that's provided related to inventories in our monolithic app. We've decided that's a domain that we want to put into its own microservice. So we create a separate microservice binary that we call the inventory microservice. And notice that it has its own dedicated database. This is crucial. Microservices are not really microservices unless the data layers are separate. We haven't begun implementing the functionality yet. We just created a binary. The next step is to set up a link between the proxy and that new binary that's running. As we implement the functionality related to inventory, we can begin using the proxy to redirect some of the traffic into that new inventory microservice binary. Once we're done implementing the functionality, we can remove that functionality from the monolithic application. Next, we tackle the next domain. Let's say we want to tackle the shipping logic. So we create a new binary, again, with its own database, set up a link from the proxy to that new microservice binary. Then, as we implement the functionality of the shipping microservice, all the traffic gets redirected, and we can remove that functionality from our monolithic application. We do the same thing for the remaining modules, create a new binary, link it up with the proxy, implement it, and now all of the functionality is gone from our monolithic app, and voila, you're in microservices. Hooray!
For Loki, fortunately, we started with something a lot more simpler. Our initial monolithic application was built with Python 2.5, and it was running with Flask. And because the way we architected our services to begin with our modules to begin with, we could easily translate basically each module into a service in our new architecture. So for the most part, that was pretty easy. However, not all the modules were simple. We had this pipeline module, which was kind of like a monster, like a Frankenstein. It did a bunch of things. It stored the pipeline configuration. It managed the states of the pipelines. It managed a catalog of stage types. And it also contained all the logic to actually run the pipeline. So when we were looking at this and we wanted to transform this module into microservices, we decided to split this module into 3 microservices. The pipeline service just managed the state and the configuration of the pipeline, and that's it. Then we had a separate service that just managed the catalog of stage types. And all the logic necessary to run the actual stages were in a GCP executor. Pretty simple.
All right. So where to get started? Well, source code and documentation, good place to start. Design docs are going to be your best friends. Create a strategy for how you're going to migrate from a monolithic app into microservices. It can be a costly refactoring process that you might have to delay feature development for a while or take some resources from other parts of your team to do. You want to create a design for your final architecture, what you want it to look like. Decide on those domains that your application needs to handle. This is actually a cool opportunity to maybe rethink some of the things that maybe weren't so pretty or good about your initial app. In Loki and Glasspane, we also created design docs for each individual microservice. This made it really clear what the entities were that were being handled by each microservice, the business logic related to them, the data layers, and more importantly, the contracts that were being established between each microservice and the other services that it needed to consume or that needed to consume it. Next, ask yourself, do you want to split up your source code repository? In Glasspane and Loki, we decided to do this. By splitting our repository into a single repository per microservice, we established clear dependency relationships between the services. This is a really cool thing about microservices to take advantage of. This also meant that, essentially, there's no other choice but to deploy them separately, which is what you want to, it's one of the key benefits to get out of it. Finally, set team responsibilities. If you're a small team, you might have one member who's responsible for multiple microservices. If you're a large team, you might have whole sub-teams dedicated to a single microservice. Decide on this, and you'll be good to go. You might be wondering, OK, if I've got a separate repository for every microservice, like here in Glasspane, you can see we had a repository for the core service, the preference service, the team service, and so on. How do I share code between them? Our solution was to add a common repository. It's not a microservice. It's just a separate repository where we can put shared code that all the individual microservices can depend on. This means we can still deploy them separately and test them separately, and they're not depending on each other.
OK, so we thought about the sizes of the services. We have a document set up in place. And then for us in Loki and in Glasspane, we were thinking, if we want to move to microservices, what technology stack do we pick? So you can run microservices in multiple ways. You can run them as App Engine applications, as a customized compute engine, in Kubernetes, in Cloud Functions, in Knative. It depends. For us specifically, we picked GKE, mainly because we could deploy a wide variety of applications in GKE. If you can put it in a container, GKE can probably run it. We were also super interested in self-healing capabilities and the auto-scaling capabilities in GKE. This meant that our application would be up and running all the time. Also, we really liked the declarative configuration in GKE. We could just basically tell what we wanted, and GKE will get it done. Also, we really liked that in GKE, we had easy network setup, and GKE basically handled the updates of our Kubernetes cluster for us, so we didn't have to manually schedule this and run it for ourselves. Plus, since our old application already leveraged most of the GCP services, we were also interested because GKE can leverage things like Stackdriver, PubSub, Datastore, and so on. For the back end, though, as our team changed, we were more experts on Java than in Python. And so we picked Spring, mainly because we knew Java, our developers knew Spring. It's a perfect fit. Spring is a very mature framework used throughout the industry. It's open source, cloud native. It's as flexible as you want it to be. If you want to, you can specifically configure something, or let Spring auto-configure itself. Also, there's tons of documentation, so it was really easy to get started. On top of that, we found that there are these two projects, Spring Cloud GCP and Spring Cloud Kubernetes. The first project basically allows your Spring Boot application to leverage things like PubSub, Datastore, authentication, and so on really easily. And Spring Cloud Kubernetes allows the Spring Boot binaries running on a GKE cluster to leverage the Kubernetes API. We'll talk about how we use both of these things in other slides.
Both Glasspane and Loki use this front-end framework called Polymer for our front-end UI. You might be wondering, why am I talking about a front-end framework in a presentation about microservices? Well, Polymer takes advantage of something called web components, where each piece of the UI is a separate component with isolated responsibility. It allows us to think about our front end in much the same way we think about our microservices back-end architecture.
Here's an example. This is the navigation bar or the sidebar for Loki, and you can clearly see how it's composed of tiny pieces, web components that interact together to create a single-page application. We encourage everyone to go check out the Polymer project and the Lit project. They're pretty interesting. We found it useful. So anyway, now we have an idea of how to split our services. We've picked a technology, and now we want to be able to expose these services to our clients, our front ends or other applications. I'm going to talk about two patterns that you could use, gateways and aggregator or composite services. Now, gateways, as the name implies, they act as a door, right? They basically decouple your clients from your downstream services. Gateways basically allow you to configure an optimal API for each of your clients. It also allows you to aggregate calls to the services. So your front end doesn't need to know that in order to get a flow, it needs to go to 3 services. The gateway can handle that for the client. Also, the gateway allows you to set up throttling rules and retry logic. So if a service is down for a moment, the gateway can retry a couple of times, and then the user doesn't even know. This is also a good place to place perimeter security. This allows you to block certain users to access any of your downstream services that you might not want to. A note is just that perimeter security should not be the only security that you add to your application. So how do we get a gateway in a Spring Boot application? You basically just add this dependency, and you're able to now match routes, write predicates and filters, and set up a bunch of things, which is really, really fast and magical. And there's this other thing called aggregator or composite services. These are basically just services that aggregate calls to other services. This allows you to maybe simplify calls or implement things like retry or exception handling. As an example, I told you at the beginning about this concept of a flow in Loki that has notification, triggers, and a pipeline. And so instead of having the front end talking to these 3 services to create just one flow, we created an aggregation services called the flow service. So now the front end can just talk to the flow service, and the flow service handles the logic of talking to these other services for the front end. It also notices if a service is down and maybe do a couple of retries if something didn't happen as we expected. Speaking of retries, how do I even configure the number of retries in my service? So when we were developing our services in Loki, we had a bunch of configuration that we wanted to add to our services. Retries, timeouts, feature flags, and we didn't want to redeploy our whole service when we changed one of these variables. Well, it turns out that the Spring Cloud Kubernetes project allows us to basically push a configuration map to our GKE cluster, and as the cluster notices these changes, it delegates that over to the services, And then you can just read these as variables annotated with the add value annotation in your application. Really, really convenient for toggling features.
Since Glasspane doesn't use Spring, we didn't have this cool configuration management right out of the box. So we decided to implement this functionality ourselves. We created this configuration microservice that listens for changes to a protobuf file, essentially sitting somewhere in a repository, containing the configuration settings for all of our microservices, like feature flags and number of retries and the things Sergio was mentioning. When this configuration service detects a change to this file, it sends a message via Cloud PubSub to all of the other Glasspane microservices to tell them, hey, the configuration is updated. And they know to update those values without having to be redeployed.
OK, so we got a bunch of services up and running. And we might want to be able to carry out complex transactions across them. Let me set an example. Imagine this. Imagine that you have a project in Loki, and a project might have additional metadata associated with it. And let's also pretend that a user wants to delete a project, right? So the project service gets a message to delete project X. For the project service, it's really easy. It just goes to its data store and deletes the project, and that's it. But there might be some cleanup that needs to happen from other services if you deleted a project. Maybe stop the triggers, or if it's a pipeline that's currently running, stop it, or something like that, right? And you want to be able to do this atomically as well. And then on top of that, imagine that in the future, the system grows, and there's new services that are available, and they also need to react to things that happen when a project gets deleted. How do you do that? It turns out that there are some patterns called Saga Patterns. I'll talk about orchestration and choreography. In orchestration, you have a single service that coordinates what's happening. This coordinator service makes sure that things happen in a certain order, or that they're even happening at all. The problem with orchestration, though, is if this magical coordinator service somehow dies, the other services don't know what to do. And so then you have choreography. In choreography, services basically produce and listen to events, and they react accordingly. There is no single service coordinating the actions. The downside to this is that there might be some overhead because you're sending events, and then all the messages have to get them. But in Loki, we use a combination of both. For the example that I was just talking about, the project service emits an event saying, hey, project X has been deleted. And through eventual consistency, the message arrives eventually to all the services who are interested in this message, and then delete the project in a fan-out strategy. The opposite can also be done. A single service might be listening to multiple events from other services. For example, we want to do this with our metrics service. We want to use the metrics service to calculate release velocity and additional metrics in our application.
Sergio covered some useful patterns for coordinating your services. But as your application grows and you're maybe using these aggregator or composite services, how do you keep track of the requests that are being sent between all of these different services? Distributed tracing is a technique to do exactly this. Zipkin is an example of a tool that Spring uses to add essentially breadcrumbs to the HTTP headers automatically to all your requests, allowing you to track them as they bounce from service to service. This means that you can troubleshoot errors and gather metrics about the way that your services are communicating. Really useful stuff. As an alternative, there's tools like Envoy and Istio that create a service mesh to enhance HTTP requests between services running on any tech stack to provide your application with distributed tracing capabilities automatically.
So for Loki, in order to implement distributed tracing, we only had to add these two dependencies to our services. After this, our Spring Boot applications began pushing information to Stackdriver. That meant that we can then go back to our Stackdriver in our GCP console, and we could actually tell and see the messages bouncing across all our services. And if you wanted to, you can even click a button to go into detail about what's happening in each individual service. How do the services even find each other? If I create a new service, how do the others know that it even exists? We're this thing called service discoverability. It's been around for a while, but it really became popular for microservices when Netflix introduced Eureka. The concept is actually pretty simple. You have something called a service registry. When new services arrive, they talk to the service registry and say, hey, I'm the project service. And then other services can query the service registry to find out what other services are available. And you can do some really interesting things with this. I'll show an example here. In Loki, we had this general trigger service, and maybe some implementations, the manual trigger and the Git trigger. And we wanted to have a way to enhance Loki to have new types of triggers without actually going back and changing the existing source code. So in order to do this, we leveraged server discoverability. If you wanted to add maybe a PubSub trigger, we just wrote the PubSub trigger in a way, drop it into the cluster, the service register with Kubernetes, and then the trigger service became aware that this service actually existed now. With that, the trigger service can go back to the PubSub trigger and interrogate the service, asking what it did. And then it could expose that functionality across the other services. But what if a service goes down? Unlike monolithic apps, one major benefit of microservices is that your whole application can somewhat be up and running even if one of those services goes down. How do you know? How do you handle this? I'll talk about some patterns, behavior patterns, circuit breaker pattern, and self-healing services. So a circuit breaker pattern is basically a pattern used to detect failures and allows your services to react to those failures. Here's an example. Imagine that a user wants to do something with the flow service. And in order for that to happen, the flow service needs to talk to the trigger service. If everything is fine, the flow service talks to the trigger service, and that's it. Imagine that for some reason, the trigger service is down. The user doesn't know that the trigger service is down, obviously, and so maybe the user will click a button to try again. Maybe the user is impatient and clicks the button again, and again, and again. And then you run into this issue where the flow service has a bunch of open connections, waiting for the trigger service to come back. And then the trigger service is dead. And so if it ever becomes available again, it doesn't know about those other requests which are in progress. And the user is super confused because the user doesn't know what's happening. So here is the same thing, but with a circuit breaker. Again, if nothing's wrong, the flow service through the breaker goes to the trigger service. Everything's fine. The call shall end, and the user is happy. But again, let's say that the trigger service is down for some reason. The flow service goes through the circuit breaker onto the trigger service, and now the circuit breaker will try a couple of times for you, depending on how you've configured this. When the circuit breaker determines that the trigger service is unhealthy, it'll get a chance to react. The circuit is open, and now the circuit breaker can actually throw out an exception in your flow service. And now your flow service can handle logic. Should you maybe tell the user that something's wrong? Maybe it'll store the request and try again after the trigger service becomes available.
So Sergio threw the pattern at you. Now I'm going to show you how can you actually implement this. So we did this in GlassPane, and here's how. We had this metric service in Java that attempts to get all the available metrics in GlassPane by sending a request to the metric microservice. But what happens if that fails? Well, as you can see here, it just throws an exception, and the user doesn't know what happened. Where are my metrics? Well, we implemented this by creating a new annotation called the method retry annotation. As you can see, it takes in a number of attempts to attempt the method, and even a fallback method, so that when that number of attempts is surpassed, it actually can fall back and say, hey, we weren't able to get a request, but here we're going to pull the metrics from the local repository in this service, maybe from previous requests, and get some default metrics to show the user. And maybe we also show an error message on the UI. This is just one way you can implement this pattern, but this is the kind of cool flexibility that's possible with microservices. Depending on your tech stack, this might be provided automatically, or you can create it yourself. And
then there's this other thing called self-healing services. For example, Kubernetes is able to monitor the state or your health of your application to find out if it's down or not. And if it is, Kubernetes is able to kill the pod and create a new instance of your applications so that it makes sure that it's always up and running. However, for this to work, you need to have a way for your application to tell Kubernetes that it's actually alive. And in Spring Boot applications, you can actually use the Spring Starter actuator. The actuator basically adds additional endpoints to report the health of your application. And if configured correctly, you can even use something called Micrometer to gather metrics about about traffic coming back and forth in your service. Also, I didn't want to leave you hanging. You can also use circuit breaker pattern and service discoverability in Spring. You basically have faint clients that you use. Notice that I don't have an IP address. You just basically name what client you want to talk to, and it goes back to the service registry and finds out who the service is, where it lives, and so on.
All right. It sounds like there's some cool benefits to microservices, but having all of these different binaries sounds toilsome, right? How do you manage all of this stuff? Building, testing, and deploying all of these services can sound like a big, daunting task, maybe as big as a monolithic app itself. How do you manage these services? Automation is your friend. There are tools out there that we really encourage you to use that will help to automate the different parts of managing your services. This can be in a CI/CD pipeline to make it so that you're deploying, testing continuously and automatically. If you're trying to do all this manually, it's not going to be feasible.
OK, so there's things that we clearly didn't cover in this presentation, but we encourage you to go out and search for these. As Soeren mentioned, you want to be able to automate the creation of your infrastructure, either through code or configuration. There are lots of tools out there like Ansible, Puppet, Chef. Google Cloud and Amazon have implementations for these things. In Loki, we use something called Terraform. You want to have a CI/CD pipeline per microservice. Make sure that you always run tests whenever a change gets pushed to one of your repositories. Have a rollout strategy. Think about how you're going to deploy the services. Are you going to deploy them always when the test passes? Are you going to have a canary? Are you going to do green-blue deployments? Think about that. Set up error logging, metrics, and reporting. You want to do this at the beginning when you're developing the services instead of waiting until the end. Obviously, don't forget about security and testing. We didn't cover this topic at all, but we encourage you to go out and look.
So, what can you take away from this presentation? Well, earlier, we talked about some of the pros and cons of monolithic apps versus microservices and how microservices came to be. We told you why we initially built Loki and Glasspane as monolithic apps and why we decided to go and push into this great adventure of converting them into microservices despite the great refactoring costs. Microservices allowed us to iterate quickly and focus on solving our users' needs. So ultimately, we got out of it what we wanted.
Throughout this presentation, we also show you how to take advantage of existing patterns, like the Strangler Pattern to slowly break down your service. We also talked about Saga Patterns to reinforce atomic operations, circuit breaker when something goes down. We use examples of Loki and Glasspane to show you how you can implement the same patterns with different technology stacks. Ultimately,
there's no one-size-fits-all approach to the perfect application. If there were, we wouldn't be here, right? There would be no point for us to talk. But we hope that you learned from our experience with Loki and Glasspane and that you took away some useful tips for how to choose a good architecture for your app. We hope the road ahead is a little clearer now. There's this cool search engine you can use to search for all the tools and things that we talked about in this presentation, in case anything is vague. But we wish you the best of luck on your journey.
Thank you.